Hello everyone. Today I'm going to talking about our topic, character identification on multi-party dialogue based on end-to-end neural coreference resolution. So this task is proposed from Semantic Evaluation 2018. And this task is we want to identify the characters, actual characters in the TV show transcripts from multi-party dialogues. So for example, if Rose say, I told mom and dad last night, they seem to tag it pretty well, then we need to identify I as Rose and mom as Judy and dad as Jack. So how we do that? First, we need to conduct an coreference resolution task. So the purpose is to do it can first do the mention detection and then cluster each mention if they corref to the same entity. However, we don't know we don't know we only know the cluster after the doing this coreference. We don't know the actual entity ID for each cluster. So we need to further do the entity linking task for uh, for identify the characters. So let's talk about our two models. The first one is proposed from Lee and Kenton this year. So the basic idea of this end-to-end coreference resolution is they don't use any other parser. They just use their model to train this document into the clusters. So in the beginning, each sentence will separate it into some words. So each word embedding will pass through the bidirectional LSTM to form some span representation. So in the meanwhile, the bidirectional LSTM will compute the span head. So each span is concatenated from the mentioned starts, mentioned ends, and this span head. And once we gather this mentioned representation, we can compute the antecedent score. So the purpose here is if the mention has a very high antecedent score with another mention, then we will say they are in the same cluster. And once we get the cluster, we need to do entity linking. So in this part, we revised the method from Chen and Henry, the paper from Cornell 2017. So in their paper, they generate agglomerative convolutional neural networks to a classifier to identify each mention into one character labels. And there are 7 character labels in our task. So basically, each data will contain 3 kinds of the embeddings. The first embedding is mention itself, and then we will compute the cluster embedding, which can include this mention. And the last one is the cluster mention pair embedding. So each mention will pair with all the other mentions in the same clusters. And finally, we will concate these 3 embeddings and then go through 2 V4 neural networks and use the cross entropy loss to optimize. And the data set is collected from 2 seasons of Friends TV show and follow the Cornell 2012 Sure Task data format. And the evaluation matrix, we use MUC B cube CEAF for coreference resolution, and we use precision for the entity linking. And there are 2 main challenges in our task. The first one is we don't have GPU resource, and the mini batch size we can only use 1 because the end-to-end released code, they they just they fix the batch size. So we need to take about 1.5 days to train the model with around 60% of F1 score. And the second one is about entity linking. We don't have cluster label data for the cluster embedding generated from the Coreference system. So we can't directly to train the end-to-end entity linking model. So instead, we just train the prediction model from mention embedding, because the Cornell dataset, each mention will have one entity ID. So, and the mention embedding are generated from the end-to-end coreference model. So our experimental results for coreference part, the normal is quite similar to the paper proposed. So the F1 score is about 66. And the interesting finding here is that if we don't use the heads features, then we will see the F1 score is quite similar to the normal one, which in this case, because our multi-party dialogue transcripts, the TV show transcripts is not really hard like Wall Street Journal or New York Times. So the word will use like only one word for each mention, or like at most 2 words. So it don't, if we just we compute the heads, it don't contribute a lot. And finally, the entity linking, we re-implement the code, the paper from chance work. So it's like we mentioned previously, use the mention embedding and cluster embedding and mention pair embeddings to train the agglomerative convolutional neural networks. However, the results are really bad. We only get around 20% of precision for 7 labels. And we want to find the reason. So we do another experiment. We just use the mention embeddings as our input, and go through one feed-forward neural network to a softmax layer to predict this 7 label. And we find the precision is also very low. So which will say that the mention embeddings is actually not quite really related to the entity ID. So in conclusion, we implement this character identification system, combining the neural coreference system and with an agglomerative convolutional neural network entity linking model, and our code can be released on the GitHub. So in the future, if we gather more GPU resource, we can collect cluster to entity labels so as to train the entity linking model end to end, and add some speakers ID information into the mention embeddings, which we think if we will have time to do that, we think we will get much more better results. So thank you for your listening.